Today we are going to discuss about the topic block cipher modes of operation. So what is meant by a block cipher? Block cipher is nothing but taking the fixed length of block of text of length b bits and a key as an input and produces the b block of cipher text. Then we can say as a block cipher. So this block cipher has 5 modes of operation which was given by the National Institute of Standards and Technology, and these block ciphers are used for the variety of applications. So what are those 5 operations? The 5 operations are electronic code book, cipher block chaining, cipher feedback mode, output feedback mode, and counter mode. So before going to the what is the operations, we need to know when we are going to use the block cipher modes of operations. So block cipher only allows to encrypt the entire block. If what if a long message is longer or shorter than the block size? If the message is longer, then what we are going to do is we are going to break according to the number of bit block. Suppose if I have 128 bit block and I can access the bit block of only 64 bit, then what I am going to do is I am going to break the blocks of plain text into 2 blocks and I'm going to process the data. What if the message is shorter than the block size? If the message is shorter than the block size, then we are going to pad the data inside it. For example, if I take suppose if I can access only 64 bit block and I have the 65 bits, then I'm going to take the first block with the 64 bits and the next block which is remaining with 1 bit, that 1 bit plus all the 63 bits which are being padded as zeros to that block 2 that is being taken. Then when message is longer or shorter than the block size, we use mode of operation. So it depends upon the algorithm and the modes of operation that we perform. The algorithm that exploits the block cipher to produce the service is nothing but the confidentiality. Electronic code book. So this is the simplest mode of operation and it divides the plain text into n number of blocks. So the block size of the each block is b bits. If the plain text is not the multiple of the block size, then the text is padded to make the last block the same size of other blocks. As we have discussed that whenever there is a shortage of the bits, we are going to pad zeros after the bits that are there. Suppose if for the total 60, if I am taking the bit block of the 64 bit and I have only 60 bits that are there in the block, then I am going to pad 4 bits zeros in the last such a manner that I can have the bit block of 64 bits. Now the same key is being used for the encryption and the decryption of the each block. Then coming to the diagrammatic formation, diagrammatic of ECB. So this you can see in the diagram we have taken the plain text and we are going to encrypt with the key and we are going to get the ciphertext. If my plain text is of 128 bit, how many blocks I am going to use? I am going to use about the 2 number of blocks since my plain text block, that is I am going to use only 64 bit block. If at all I am going to use the bit block of 128 bit and I have the plain text also 128 bit, so the number of blocks I am going to use is only 1. So depending upon the bit size, the plain text size that we are going to process, the number of blocks attains. So at the decryption end also we are going to take the ciphertext, then we are going to decrypt with the key and we are going to get the plain text. Coming to the next method, that is cipher block chaining. So what is the cipher block chaining? Here also the message is broken down into number of blocks which are linked together in an encryption mode. And each previous cipher block is chained with the current plain text block. Hence we can say it as a cipher block chaining. So what we are doing? We are taking the plain text, we are encrypting the data with the key, and the output from that particular encryption, when we are getting as a cipher text, this cipher text will be given for the next round as the next round for the plain text. So we are taking the output as an input for the next block. So we can say this as a cipher block chaining. So since we don't have the previous, for the first block, since we don't have the ciphertext, we are going to assume the initialization vector. So this initialization vector is the some values that are placed accordingly to the bit size, and we are going to start the process. So our formula to get the ciphertext is nothing but encryption of the plain text XORed with the previous ciphertext block. So since the first block does not contain the ciphertext, we are going to take the initialization vector. So the initialization vector prevents the same plain text from making the ciphertext. So these are used for the bulk data encryption and also provides the authentication. In the electronic code book, since it is the simplest form, you can observe that whenever we apply the plain text, and we are going to get the ciphertext. For the intruders, for the attackers, when they apply the same plain text, we are going to get the same ciphertext. For that reason, in this cipher block chaining, we are going to take the cipher block as the plain text for the next block. So you can observe here in the diagram that for the plain text, we are applying or XORing with the initialization vector, and we are encrypting the data with certain key, and you are getting the ciphertext. Now this ciphertext is used for the XORing with the plain text for the next block. Now plain text 2 is being taken, and we are going to XOR with the previous ciphertext, and we are going to encrypt the data with the key that being used, and we are going to achieve. So in the comparison between the electronic code book and the cipher block chaining. So cipher block chaining will be more complex, because here we are taking the ciphertext for the XORing. There you can easily, attacker can achieve the once the same plain text is given. But here, even if the same plain text are given, we are going to get the different ciphertext values. And at the decryption end also, we are going to take the ciphertext, decrypt with the key that is given in the encryption, and we are going to apply the initialization vector, and we are going to attain the plain text. The reverse process of encryption here. Then coming to the advantages and limitations of the cipher block chaining. So ciphertext block depends only on all blocks before it. Any change in the block affects allow the following ciphertext blocks. So one change in the ciphertext of the first block will affect all the blocks in the next one. So that effect we can say as an avalanche effect. So it needed the initialization vector. The advantages, like I said, the randomness, that is whatever the, even if there's two plain text of same block, if we are going to attain the different cipher text. So that is the advantages in the cipher block chain. Coming to the stream mode of operation. So in the previous one, that is electronic code book and the cipher block chaining belongs to the block modes, and the other three, that is cipher feedback mode, output feedback mode and counter mode, belongs to the stream mode of operation. Coming to the cipher feedback mode. So in the cipher feedback mode, we need to give the initialization vector. So we are going to encrypt with the key and we are going to select the S number of bits. So we are taking the initialization vector, we are encrypting with the key, and once you get the output after the encryption, there we are going to select number of S bits. Only S number of bits are being selected, and these S number of bits will be XORed with the plain text of S bits, and you are going to get the ciphertext values. Now this cipher value will be given for the next plain text values. Now since here we are taking the number of bits, that is n number of bits, and we are encrypting, here we are only selecting the how many number of bits, S number of bits. So the number which is, that is n minus S bits, are being transferred over here. So you can say as B minus S bits. The S bits that are being selected will be XORed with the plain text. The discarded bits that are there will be shifted over here. Now these bits and the S bits that is coming from the ciphertext will be given as a left shift. It will apply a left shift round, and once the left shift is finished, then again we are going to encrypt with the key, and again we are going to select S number of bits, and we are going to XORed with the plain text 2 here, which is of size again S bits only. Now we are going to get the ciphertext 2. Now here, since the S bits are being selected, the B minus S bits that are there will be shifted to the next block B minus S bits, and the S bits that are coming will be given to the S bits over here. Then again we are going to encrypt with the key. Then we are going to select S number of bits that are there, and we are going to XOR with the S bits of the plain text, and then we are going to get the ciphertext block. So like this the process continues till the number of blocks that are there. And at the decryption end also we are going to take the initialization vector. So in the stream mode cipher operation, we can observe that in the encryption side and the decryption side, we are going to use the encryption algorithm only. And you can observe here, we are applying the encryption with the key, and having the S and B minus bits, we are selecting only S bits, and we are also taking the cipher block. When you are XORing, you are getting the plain text values. So this cipher bits, from where you are getting the cipher bits, are coming from the previous one. Since we have applied over here, the reverse of it we are going to apply for the decryption end. So coming to the cipher feedback mode, these are the operations, that is to get the ciphertext, we are going to take the plain text XORed with the most significant bits of the encryption and the initialization vector. Similarly, to get the plain text, we are going to apply the ciphertext XORed with the most significant bits of encryption and the initialization vector. So these are the values that we are going to take. Now coming to the output feedback mode. So in the output feedback mode, similar to the cipher feedback mode, here also output feedback mode. The only difference is we are going to take the encrypted value and we are going to apply for the next block data. So in the previous cipher block chaining, we have taken the output from the cipher and we have given as a plain text for the next block. But here we are going to take the value from the encryption end and we are going to give as a plain text for the next block. So here we are going to apply the nonce. The nonce is also like the initialization vector which cannot be predictable, which is unpredictable, and we are applying that to the key and we are encrypting, and when we are from the output from the encryption we are given to the plain text and we have applied the XOR function, we are going to get the ciphertext values. So the output from the encryption will be given as the input for the next block. Then we are going to encrypt with the key, then XOR with the plain text 2, then we are going to get the cipher block 2. So like this the process continues until we have the number of blocks. So coming to the decryption end also, we are going to apply the encryption algorithm only for the stream mode of operations. So we are going to take the nonce, then we are going to apply the key and encryption algorithm. We are going to take the cipher text and XOR. We are going to get the plain text. And the same encryption value will be given and we are going to encrypt with the key. Then we are going to XOR with the cipher 2 values. Then we are going to get the plain text 2. So like that we are going to apply for the output feedback mode. So the only difference that you can observe is in the output feedback mode, we are going to take the after the encryption only we are going to apply for the next number of blocks. But in the cipher feedback mode, once the encryption is performed, then we are going to XOR with the plain text. That ciphertext will be given for the next block. This is the cipher block chaining. This is the cipher feedback mode. This is the output feedback mode. So the output feedback mode, you can see the initialization nonce we are going to give. Then the output is nothing but the input is nothing but the we are going to apply. Then encryption of the key and the input values. Ciphertext is the plain text XOR with the output. Then we are going to get the ciphertext values as plain text of n plus XORed with the most significant bits of output of the previous one. Then coming to the counter mode. So here the counter mode we are going to apply the number of counters. So for example here we are here we are going to take the counter 1, counter 2 and till the number of blocks we are going to increase our counters. Then we are going to encrypt with the key and from that encryption we are output from the encryption we are going to XOR with the plain text, we are going to get the ciphertext values. And here also at the decryption end also we are going to take the counter value, encrypt the data with the key, then output from the encryption we are going to apply these ciphertext values and XORing we are going to get the plain text values. But in this method when you are applying the counter modes, that is 0, 1, 2, 3 and so on, since the counters are incremented, we are going to give the incrementing values only, then the attacker will be easily known the information. So for that reason, this counter is again added with the nonce value. This nonce is nothing but the randomly we are going to pick some numbers, that is nothing but initialization vector which is unpredictable by the attacker. So when you are encrypting, the ciphertext values become changed. So like that even if you apply the nonce values of same values, then also you are going to get the ciphertext as different values. So in the counter mode, you can say in counter mode there is no feedback. So we are not applying the chaining block where the ciphertext is being given to the next plain block, we are not applying. So there is no feedback. Now, the pseudo-randomness in the key streams are achieved by using the counters. So, a n-bit counter is initialized to predetermine the value initialization vector and incremented based on the predefined rule, that is mod 2 power n. To provide the better randomness, the increment value can depend upon the block number to be incremented. The plain text and the cipher block text block have same block size as underlying cipher. So you can see here for the encryption process, we are going to take the initialization vector, then we are going to plain text and encrypted with the encryption with the key counters. So you can take the nonce. Suppose if I have total 128 bit, I am going to take the 64 bit of the nonce and 64 bit of the counter. Since here we have taken the simple values as counter as 0, 1, 2, 3 and so on. So you can put the counter values as the nonce values and we are going to encrypt with the key and we are going to XOR with the plain text. Then we are going to get the ciphertext block. So counter decryption process. So in the decryption end also you can observe that we are taking the nonce value and the counter value. Then we are going to encrypt the data with the key and applying the ciphertext, XORing with the encryption values, we are going to get the plain text. Here the attacker can own, unless he knows the nonce value, it is very difficult to find out the what may be the plain text. Since these nonce values are unpredictable, the attacker has to find out the different combinations to find out that particular plain text. Thank you.